Hello students! Today we are going to discuss about the Seafloor Spreading Theory. In this lesson, you are expected to explain the Seafloor Spreading Theory, simulate and describe the seafloor spreading process, calculate the rate of seafloor spreading using the magnetic loose, enumerate and explain the evidences of seafloor spreading theory, and explain the importance of the seafloor spreading process relative to the continental drift theory. But before we discuss the seafloor spreading theory, let's recall first our past lesson on continental drift. Continental drift theory states that all continents were once one large landmass called Pangaea that broke apart and where the pieces move slowly to their current locations. Evidences of continental drift theory includes the feet of the continents, fossil records of the prehistoric organisms, similarities of rocks and mountain ranges, and coal and glacial deposits. However, despite these evidences presented by Alfred Wegener, his idea on continental drift was not accepted by his colleagues because he failed to explain how the drifting of the continents took place. This made scientists conduct further studies in search for the answers on how the continental drifting took place. With the advancement in modern technologies and new techniques, scientists were able to gather information and map the ocean floor. With the use of sonar devices and submersibles, scientists were able to discover underwater features deep within the ocean floor. They found a system of ridges or mountain ranges on the ocean floor similar to those mountain ranges on the continents. These are called the mid-ocean ridges. One of the famous mid-ocean ridges is the Mid-Atlantic Ridge. In the early 1960s, scientist Harry Hess proposed that the movement of the continents was a result of seafloor spreading. What is a seafloor spreading? Let's find out by doing a simulation activity. In this activity, you will need the following materials: board paper, or you may make use of a paper folder, long-sized coupon band, pentel pen or colored pencil, pair of scissors, paste or glue or scotch tape, and ruler. Please follow the procedure in the activity. Now let's answer the guide questions in the activity. What do the stripes in the paper represent? The stripes represent the rocks with normal and reverse polarities. What does the middle slit represent? What occurs in this region? The middle slit represents the mid-ocean ridge where the actual seafloor spreading occurs. What is the role of the mid-ocean winds in the movement of lithospheric plates? The mid-ocean winds is the origin of the lithospheric movement. It is where the force that pushes the lithosphere originates. How does the new seafloor form at the mid-ocean winds? Hot, less dense material below the Earth's crust rises towards the mid-ocean winds. As this material flows sideways, it creates a crack in the crust where magma will flow out. This magma cools down and becomes the new seafloor. What process or processes happen at the side slits? The side slits serve as a subduction zone where the old seafloor plunges beneath another tectonic plate. Is the Earth getting larger and wider when plates drifted away from each other? Explain briefly. The Earth is not getting larger or smaller. If there is the production of a new seafloor in the mid-ocean winds, there is a destruction of old seafloor at subduction zone. We now discuss the seafloor spreading theory. As we have mentioned earlier, that in the early 1960s, Harry Hess proposed this theory. In 1962, he added a geologic processes to account for Wegener's continental drift. It was possible, he said, that magma from beneath the Earth's crust could flow out between the tectonic plates in the Great Global Rift. As this magma cools, it would expand and push the plates on either side of it, where the North and South America move to the west and Eurasia and Africa move to the east. Harry Hess proved Wegener's idea was right and clarified the mechanism that broke the once joined continents into the 7 continents we know today. The continents are attached to the plates so that when the plates move, it carries the continents with them. And this is the first evidence of the seafloor spreading. We call it the evidence from molten material. Magma erupting along mid-ocean ridges cools down and hardens quickly, forming rock shaped like pillows. Seafloor spreading was strengthened with the discovery that the magnetic rocks near the ridges follow a magnetic pattern. We call this evidence the evidence from magnetic stripes. As the molten rock hardened, this magnetic material inside the rock lined up in the direction of the Earth's magnetic field. This forms unseen magnetic stripes. The magnetic poles reverse themselves. These stripes are mirror images on each side of the mid-ocean winds. Another evidence of seafloor spreading is the evidence found from drilling samples. Hess found out that those rocks near the mid-ocean ridges were younger, while those rocks found far away from mid-ocean ridges were older. Now that you know and understand the seafloor spreading theory, we try to find out how fast the seafloor is spreading by doing the next activity. In this activity, you will need the magnetic field graph, ruler, calculator, and pencil. Please follow the procedure in this activity. Shown here is the magnetic field graph. You will be working only with normal polarity readings. These are the peaks above the baseline on the top half of the graph. Place the long edge of the ruler vertically on the graph. Then slide the ruler so that it lines up with the center of peak 1 west of the mid-Atlantic ridge. Determine and record the distance in inches that line up with the center of peak 1 west. Repeat this process for peak 1 east of the rays. Do the same for the remaining pairs of normal polarity peaks. We summarize the answers in this table. Calculate the rate of movement in centimeters per year using the equation rate is equal to distance divided by the time. For example, for peak 1 west, the time is 2 million years and the distance is 25 kilometers. Calculate for the rate. Rate is equal to distance, which is 25 kilometers, divided by the time, 2 million years. The rate is equal to 12.5 kilometers per million year. To express the 12.5 kilometers per million year to centimeters per year, we convert using the conversion factors. So, the rate is equal to 12.5 kilometers per million year times 1 mega year, or this is just equal to 1 million years, since mega is 1 times 10 to the 6 or 1 million, times 1,000 meters over 1 kilometer, times 100 cm over 1 meter. Therefore, the rate for peak 1 west is equal to 1.25 centimeters per year. Please do the same process for the rest of the given peaks. So we now summarize the concepts we discussed about seafloor spreading theory. I hope you've learned how to calculate the rate of seafloor spreading and remember other concepts we discussed in this lesson. So till next time in our next lesson.